Today we're going to talk about graphing exponential functions. So last time we talked about exponential functions looking like this, a times b to the power of x. Okay, we're going to take functions that are in this form and graph them using tables. So here's a quick example. If our a value is 3, our b value is 2, and I plug that into a table, I put 0 in for x, so it'd be 3 times 2 to the power of 0. I end up with 3. And then we can try 3 times 2 to the power of 1, and our answer is 6. So that gives us 2 points to help us create our curve. We are going to use 4 points because 2 isn't quite enough to show where the curve goes. 2 is enough to make a line, but it's not enough to make a nice exponential curve. One thing I want to point out here, if the b value is less than 1, this value right here in the parentheses, then it is going to be a decay, meaning that the numbers are going down, it's decreasing. If that b value is greater than 1, then it will be increasing. It cannot equal 1. All right. So our first example, we have 2 to the power of x, so I can plug in 2 to the negative first power, and you're probably going to want a calculator for most of these. We haven't talked about negative exponents before, so if you put this in your calculator, you're going to get 1/2. Or if you want it as a decimal, you could put 0.5. It doesn't matter if it's a decimal or a fraction, as long as you know how to graph it. So if you're better looking at a decimal to figure out, okay, 0.5 I know is going to be halfway between 0 and 1, or half would also be halfway between 0 and 1. However you like to think about it, sometimes, especially fractions that you're not familiar with, it might be better to have it as a decimal. 1/2 is pretty easy, so it could be either way. Okay, then we try 2 to the 0 power. Again, you can put that in your calculator. We should get 1. So 0, 1. 2 to the first power, that's nice and easy, is just 2. And then 2 squared, 2 times itself, is 4. So now with these 4 points, we can really see where this curve is going. 2 is not quite enough. Sorry, my curve's not the greatest. Okay, and we see that this is a growth. It's going up. We could have noticed that at the very beginning because our b value is greater than 1. In this case, we did not have an a value. That's okay. Sometimes we don't have an a value. That's just 1. So the b value is always what is going to be with the exponent. So in this case, it's 2, which is greater than 1. It's growth. I look at this one, and it's 1/3, so I know it's going to be a decay. So if for some reason my numbers were telling me to go up, I know something is wrong because it should be a decay. So if we do 1/3 to the negative 1 power, we end up with 3. And then 1/3 to the 0 power is 1. Anything to the 0 power is 1. 1/3 to the first power would be 1/3. Again, if you'd rather have a decimal, you could put 0.3 repeating. So 0.3 would be somewhere around here. It does not have to be perfect when you're getting some of these decimals or fractions that are between numbers. Just as long as we can kind of see where that curve would go. Then we have 1/3 to the second power. That's going to be 1/9, which is actually 0.1 repeating. So it's again getting smaller, very close to 0. So I see this is a decay. It's our curve going down. It does kind of flatten out towards the end. Notice I did not keep this going down further below the x-axis. I just kind of flattened out. That's what exponential functions do. They get really, really close to 0, but they don't actually touch it. I'm going to jump to number 4. So if you guys flip your notes over to the other side, we're looking at number 4. And I wanted to look at a few that had an A value because the first 2 that we did not have an A value. They had an A value of 1, so we only saw the B value. So a couple more examples where I see that A value of 2 and the B value of 3. This really should have parentheses here. So we can do, we're going to start with -2 this time just for what's going to fit on our graph. So 2 times 3 to the power of -2. If you need help putting this in your calculator, please ask. I think I showed everyone how to do something like this on each different calculator, but if you don't know, maybe ask someone else in class or ask me for some help. Okay, this will give you 2/9 or 0.2. So remember how I talked about fractions that you're familiar with. Many of you are probably not familiar with 2/9. It might be easier to look at 0.2 to know, okay, that's going to be pretty close to 0. And then we try 2 times 3 to the -1st power. That's going to be 2/3 or 0.6 repeating. You could say 0.7 since it is 6 repeating. So that would be just a little bit higher. And then we have 2 times 3 to the power of 0, and that is going to be 2. So we graph 0, 2, and then one more. This one will be 6. So we have 1, 6, 6 is at the top of our graph. So we see another growth. Ooh, sorry about that line. We also could have known it was going to be a growth because the 3 is our B value that is bigger than 1. Last one, I see this B value is a half, so it should be a decay. 4 times 1/2 to the -1st power is going to be 8. So our graph doesn't quite have 8. We're just going to go off the graph a little bit. We're at -1, 8, somewhere around there. Then we do 0 and we get 4. One will give us 2. And 2 will give us 1. So this is definitely a decay. And this is how we graph exponential functions. I know I did this part rather quickly where I was getting these answers. If you're using a calculator, it might take you a little bit longer. That is totally fine. You also don't need to fill this in every single time. If you are understanding what it looks like when you plug x in, that is fine if you jump from x to getting y value from your calculator. I want you guys to try the rest of the note sheet. Maybe compare with a partner when you're done.